Find the unknown entries A, B, C, D, E, F in the following distribution of heights of students in a class. So we have been given a table, a frequency distribution table along with the cumulative frequency, and there are some points not available to us that we have to find out. Let's do that. So we have been given a table of heights in different classes, the corresponding frequency and the cumulative frequency. Okay, and then we have a lot of unknown values here that we have to find out. Okay, and it's also given that the total frequency is 50. From the very first class interval, the frequency is given, and it also means that the cumulative frequency will be same as the frequency because it's the first class. So we can say that A is equal to 12. Let's move further. We need to find B. For the second class interval, we can imagine a scenario of height below 160, and for height below 160 we have the cumulative frequency as 25. This 25 means it is a sum of B and 12. So I can write 25 is equal to B plus 12, and it means that B is equal to 30. Now we know A and we know B. Okay, we have to find C. What will be the value of C? C will be a sum of these three values, that is 12 plus B plus 10 will be equaling C. So I can write C is equal to 12 plus B plus 10, and we get C as 35. Next we have to find D. What will be the value of D? We have the cumulative frequency as 43, and 43 will be a sum of all these values, that is 12 plus B plus 10 plus D will equal 43. So I can write 43 is equal to 12 plus B plus 10 plus D. I have the value of B as 13. I'll resubstitute back and I will get D. Once you do, you will get D as 8. To find D, there is one more way to look at it, that is 43 will be equaling C plus D. Once more, 43 will be as same as C plus D. Once you add C and D, you will get 43, and we have just calculated C value here, and this may be a quick way for some of you. So you can prefer either continuous addition and equating to a cumulative frequency, or you can use this methodology, right? I will do this to find E. See, to find E, what I can do, it will be 43 plus E, you will get 48. 48 is equal to 43 plus E, implies E is equal to 5. I can find this way, that is this way, or the first method, that is I add all these points. Okay, I add 12 plus B plus 10 plus D plus E, I will get 48. This way also you will get the same E value. So whatever method you prefer, you do that. And the last value is F. F I can find as 48 plus 2 will equal F, or 12 plus B plus 10 plus D plus E plus 2 will equal F. Both ways are fine. I will go for the simple way, that is 48 plus 2 is equal to F, that means F is equal to 50. So I have all the values: A equal to 12, B equal to 13, C equal to 35, D equal to 8, E equal to 5 and F equal to 10. Weekly income of 600 families is tabulated below. So we have a table consisting of weekly income provided in different class intervals, and correspondingly we have the number of families, that is the frequency. I have to compute the median income, that is the income that will come at the exact middle of this data set. Let's do that. So I have the table ready. Okay, in the question we have been given this information, that is summation fi is equal to 600. That means n equal to 600. That means we have information of 600 families. So what will be the middle point? It will be n by 2 is equal to 300. Okay, in this particular question we have to find the income of the 300th family. Okay, that will be the exact middle value or the median income. So keep this in mind, that is the middle value is 300. Okay, now what I will do is that I will find the cumulative frequency and I will denote as CF. Okay, so the first value will be as same as frequency, that is 250. The second value will be 250 plus 190. I will get the cumulative frequency, and that will be 440. Okay, now see that by the second class interval, that is for weekly income 1000 to 2000, the cumulative frequency reaches 440, and we have seen that the middle value is 300. That means the middle value will be in this particular class, that is 1000 to 2000. So I need not do all the other calculations, that is not required. We can directly jump into the equation of median, and that is median is equal to L plus n by 2 minus CF divided by F whole into H. Okay, so let's substitute. What is L? L is the lower limit of the median class. So we have the median classes. So the lower value of median class is 1000. 1000 plus n by 2 is nothing but 300, and the cumulative frequency, this cumulative frequency is the cumulative frequency of the preceding class, that is 250. So minus 250 divided by F. This F is what? This F is the frequency of the median class, so that is 190. 190 into H. What is H? H is the class size, that is again 1000. You do all the calculations and you will get median as 1263.15. The median income is 1263.15. The weight of coffee in 70 packets are shown in the following table. So we have a table providing weight in different class intervals and the corresponding number of packets in each classes. Determine the model weight. So from the table directly we can see that the highest frequency is for the class 201 to 202 grams, and the corresponding frequency is 26. So this is the model class. Okay, now let's find the mode weight or model weight. So we have the equation. Mode is equal to L plus F1 minus F0 divided by 2F1 minus F0 minus F2 whole into H. So now we will substitute the values and we get L is the lower limit of the model class, that is 201. Okay, F1 is what? F1 is the frequency of the model class, that will be 26. F0 is what? F0 is the frequency of the preceding class, and F2 is the frequency of the succeeding class. Fine. And H is nothing but the size of the class intervals. So we will substitute and we get 201 plus 26 minus 12 divided by 2 into 26 minus 12 minus 20 into 1. Substitute and you will get the answer as 201.7 kg. Two dice are thrown simultaneously. What is the probability that the sum of the numbers appearing on the dice is 7, a prime number, and 1? So we will solve this one by one. The first one is 7. So when you throw a dice, we will have a total of 36 possibilities, right? Total possibilities are 36 for a 2 dice. Now the first thing is that the sum of the numbers appearing on the dice has to be 7. So what are the possibilities to get 7 as the sum of two numbers? Let us list it down. The favorable outcomes will be, we can have 1 6 as 1 and the reverse is possible, 6 1, okay. And second is 3 and 4, 3 plus 4 is 7. We can also have 4 comma 3, okay. And then we can have 2 5, or we can also have 5 2. So these are the possibilities in which the sum of the numbers on the two dice will be 7, okay. So we have 1 2 3 4 5 6 favorable outcomes. Therefore the probability will be 6 by 36 equal to 1 by 6. Let's move to the next problem, a prime number. So what are the possible prime numbers that we can expect when we throw two dice together? That means the sum of the numbers. The maximum sum that we can get is 12, right? That is, when we get two dice as 6 and 6, then 12 will be the largest sum that we can get when we throw two dice. So what are the list of all possible prime numbers less than 12? We have 2, 3, 5, 7, and that's it. No, we can have 11 also. So there are 5 possible prime numbers that we can get when we throw two dice and we count the sum of the numbers appearing on it, okay. Now what we do is that we will see what are the favorable outcomes. To get 2, we need to have 1 comma 1, okay, that's the only possibilities. To get 3, we can have 1 comma 2 or 2 comma 1, both are possible, okay. To get 5, what are the possibilities? We can get 1 4 or 4 1, both are possible. Then we can expect 2 3, okay, or 3 2, and then that's it for 5. For 7 we can expect, what are the possibilities? We can have 3 4, okay, or 4 3. We can also have 2 5 or 5 2, right? Any more? Yeah, we can have 1 comma 6, right? 1 comma 6 or 6 comma 1. That's it. And for 11, what are the possibilities? We can have 5 6 or we can have 6 5. Any more chance? No. So together we have 1, 2 outcomes here, 4 outcomes here, 6 outcomes here, and 2 outcomes here. So together that is 1 plus 2 plus 4 plus 6 plus 2. So the probability of getting a prime number as the sum of rolling two dice is 1 plus 2 plus 4 plus 6 plus 2 divided by the total possibilities, that is 36, and once you do, you will get 15 by 36 or 5 by 12. Last question is, we have to get the sum of rolling two dice as 1, and any chance of this? No, there is no chance. That means the probability is 0. we cannot have a situation where we will get the sum of two numbers as 1 when we roll 2 dice. 2 dice are thrown at the same time and the product of the numbers appearing on them is noted. Find the probability that the product is less than 9. So what we have to do is that we have to find the probability of product is less than 9. Let's do that. When we roll or when we throw 2 dice, what are the possible product that we can get when we throw 2 dice? Okay, what are the two extreme product that we can get? It can be 1 into 1 equal to 1, that is the lowest product that I can get, and the largest product I can get is 6 into 6, right? The smallest product possible is, it's for 1 comma 1, okay, then we will get 1 as the product. The largest product possible is for 6 comma 6, and then we will get 36. Now to solve this, what I will do is that I will choose a number on the first dice, and then I will see what are the possibilities for the second dice in such a way that the product will be less than 9. Let me do this. So I'm checking the favorable outcomes. Okay, we know that the total possible outcomes will be 36 for rolling 2 dice together. Now we are just going to find the favorable outcomes. So let's say I get number 1 from the first dice. Okay, now what I'm going to do is that I'm checking what are the possible numbers that I can get on the second dice such that the product will be less than 9. So with 1 appearing on the first dice, we can have any number on the second dice, right? If the second dice is having number 1, then 1 into 1 is going to be 1, it is less than 9. And let's say the other extreme, that is I get 6, okay. If I get 6, 1 into 6 is equal to 6 and it is less than 9. That means I can have any number on the second dice and all will be a favorable outcome. So I can have 1, 2, 3, 4, 5, 6, all are possible. That means I can have 6 outcomes favorable. Okay, now let's go to the second. That means I get number 2 on the first dice. Now I will see what are the possible numbers that I can get on the second dice such a way that the product will be less than 9. Okay, what are the possibilities? 2 into 1 is going to be 2, it is less than 9, and 2 into 4 is going to be 8 and it is going to be less than 9, but 2 into 5 we will get 10, which is more than 9. So I can have 1, 2, 3 and 4, right? Only 4 numbers are possible on the second dice. That means 4 possible outcomes. Okay, again why 4? 2 into 4 is 8 and that is less than 9, but if 5 was there, then 2 into 5 is going to be 10 and it is not less than 9. Okay, we move further. 3. What are the possible numbers for 3? 3 into 1 is going to be 3, it is less than 9, and 3 into 3 is 9, so it is equal to 9 and not less than 9. So only 2 possibilities are available, 3 into 1 and 3 into 2. Both will get a number less than 9. So 1, 2. That means I have 2 possible outcomes. For number 4, that is I get number 4 on the first dice. Now what are the possible outcomes? I can have 4 into 1, okay. 4 into 2 is possible. 4 into 3 is not possible because 4 into 3 is 12 and that is more than 9. So only 2 outcomes, 1, 2. I can have 5 into 1, it is going to be 5 less than 9. 5 into 2 is going to be 10, it is not possible. So I can only have 1, that means only one possibility. Similarly for 6, I can only have 6 into 1. 6 into 2 will be 12, it is more than 9, so only one possibility. So together, what are the favorable outcomes? It is going to be 6 plus 4 plus 2 plus 2 plus 1 plus 1. That will come to be 16. So the required probability is 16 by 36 or 4 by 9. Two dice are numbered 1, 2, 3, 4, 5, 6 and 1, 1, 2, 2, 3, 3 respectively. They are thrown and the sum of the numbers on them is noted. Okay. Find the probability of getting each sum from 2 to 9 separately. Probability of the sum of the numbers on the two dice from 2 to 9. Okay. And in this problem there is a difference in dice 2. On dice 1 I have a regular dice, but on dice 2 I have a different set of numbers. It is going to be 2 1s, 2 2s and 2 3s. In this particular problem, the total number of possibilities will be still 36. Okay, that is not going to change because we have 6 numbers here, 6 numbers here. That means the total possible outcomes will be 6 into 6, 36 possible outcomes are there. Now we have to find the favorable outcomes. Okay, again what I will do is that I will keep the dice 1 as constant and I will check what are the possible outcomes with dice 2. Okay, let's start by finding the probability of the sum of the numbers on the two dice as 2. Then we go step by step up till 9. Okay, so starting with probability of the sum of the numbers of the two dice as 2. So on the dice 1, let's say I get number 1. On dice 2, what are the possible outcomes? I can only have 1, right? Then only I will get 1 plus 1 equal to 2. But on dice 2 we have 2 ones, okay, not just a single one. I have 2 ones. That means I can have 1 or the second one, and together I can have 2 possibilities. Fine. For any other number on dice 1, let's say I get 2 on dice 1. Is there any possibility on dice 2? Nothing. No number on dice 2 will end with the sum of the number equal to 2. So probability of 2 is going to be, there are 2 favorable outcomes, okay, 2 by, and total possibilities are 36, that means 1 by 18. Now the second probability of getting the sum of the numbers as 3. Okay, let's say I'm getting number 1 on the dice 1. Okay, now what are the possible numbers on dice 2 such a way that these two when I add I will get the sum as 3. I can have 2. Okay, 1 plus 2 is going to be 3, and there are 2 2s on dice 2, right? That means totally there are 2 possibilities. So on dice 2 I can have 2 comma 2. Fine. Now what happens on dice 1? I get the number as 2. What are the favorable outcomes on dice 2? On dice 2 I can have 1. 2 plus 1 is going to be 3, and I have 2 ones in dice 2. That means there are 2 outcomes possible. So I can have 1 comma 1, and together I can have 2 outcomes here and 2 outcomes here. So the probability of getting a 3 is 2 plus 2 divided by 36, or nothing but 1 by 9. I check the probability of getting the sum of the numbers from the two dice as 4. On dice 1, let's say I get number 1. What are the possible numbers on dice 2 such a way that the sum will be 4? I can have only 3, and there are 2 3s possible. So together there are 2 outcomes possible. 3 and 3 are possible, and together I can have 2. possibilities. Let's say on dice 2 I get number 2. What are the possible numbers on dice 2 in such a way that sum as number 4? There are only 2 and 2. So 2 and 2 I can get, and together I have 2 possibilities. And this time I can have number 3 on dice 1, and I can have number 1 on dice 2 and number 1 on dice 2, and together I can have 2 possibilities such a way that the sum will be 4. So 1 comma 1 and together 2 possibilities. Altogether probability of getting a 4 is, I have 2 plus 2 plus 2 divided by 36. Again, what are these? These are nothing but the favorable outcomes. So I'll get 6 by 36 or 1 by 6. What is the probability for number 5? I can have number 1 on dice 1, and the possible numbers on dice 2 are nothing. Okay, no number on dice 2 will give me a sum equal to 5. Nothing here. Okay, now let's say I get number 2 on dice 1. What are the possible numbers on dice 2? I can have 3. Okay, again I can have 3. So there are 2 outcomes possible. 3 and I can have 3. Okay, and together 2 outcomes possible. What if I get number 3 on dice 1? What are the possible outcomes? I can have 2 and I can have 2, and this will always come to be a sum of 5, and that means I have 2 possibilities. 2, I can have 2, and together 2 possibilities. Again I can have number 4 on dice 1, and I can get number 1 and number 1. 4 plus 1 is 5, that means I have 2 possibilities. 2 possibilities. If I get number 5 on dice 1, is there a chance? If it is, the minimum number is 1 and 5 plus 1 will be 6, and this is not possible. So probability of number 4 is nothing but 2 plus 2 plus 2 divided by 36, and you will get 6 by 36 or 1 by 6. Similarly, you can continue to do for probability of 6 to 9. You will get probability of 6 as 1 by 6, probability of 7 as 1 by 6, probability of 8 as 1 by 9, and probability of 9 as 1 by 18. A coin is tossed 2 times. Find the probability of getting at most 1 head. The thing with probability questions is that it can be confusing to some of you, or you are not able to clearly understand the problem, right? Especially with the English wordings like at most, at least. It is important that we all understand the question very clearly, because then only we can solve the problem. If you are not able to understand the problem itself, then solving it is not going to happen. So in probability question, the phrases like getting at most 1 head or getting at least 1 head, these things may be confusing for some of you, but with regular practice you will be able to understand what is asked in the question. Okay, so we have to practice and learn, and in this particular problem we are being asked find the probability of getting at most 1 head, and what it means is that we have to get not more than 1 head. Okay, what I would do is that I will first write all the possible outcomes in this particular problem, that is tossing a coin 2 times. So total possibilities are going to be head and head. I can get tail and head, or head and tail, or I can get tail and tail. Now let me write the number of heads in each of the outcomes. Okay, so in this particular case I have 2 heads, that means I will get 2 heads. Okay, in this I have only 1 head, again 1 head here and 0 head here. Now in this problem we are asked probability of getting at most 1 head. What it means is that we have to find the probability of not more than 1 head. Okay, so I can have 0 head one head but nothing more than 1. So what are the possible outcomes? Only these 3 are the possible outcomes where I will get at most 1 head or not more than 1 head. So the probability will be nothing but when you toss 2 coins, we know there are 4 possibilities, right? So we have 4, and out of which we have only 3 favorable outcomes. So that is 3. So the answer is P equal to 3/4.